All right, welcome everybody. My name's Pete LePage. I'm a developer advocate on the Chrome team at Google.
And I'm John Mellor. I work on Chrome for Android web browser in London.
Awesome. Today we're going to be talking about high DPI and how we make the web beautiful. Everybody here got a Pixel yesterday, and it's pretty awesome. You've all probably been surfing around a little bit on it and have seen that, you know, some websites look pretty fantastic and other sites, they don't look so good. So we're going to talk about how to make all websites look pretty fantastic. Now, how many people have an HD TV at home? Yeah, pretty much everybody, right? It looks beautiful if you're a sports fan. Everything looks sharp. It's clear. You can see all the little balls. You can see the pucks, whatever it happens to be. But every once in a while, you come across a TV show that's broadcast in standard def, and you kind of go, wow, this looks like, well, it just looks bad, right? It just doesn't look very good. We're at the same point with high DPI displays as we are with HD TVs 5 years ago. For the most part, it's up to the broadcasters to send out high def channels. Well, now it's up to us as web developers to send out the high def content to our users. So we're going to talk about how we get there. So let's just sort of think a little bit about how an HD TV works and how the Pixel works, or high DPI displays work. So with a high def TV, it's got about 1080 pixels high, right? Well, a standard def image is only about 480 pixels high. So you've got two options. One, you can display the image at sort of a 1-to-1 pixel ratio. So it's not expanded out, everything looks sharp, it looks good, but you've got all those black borders around everything, and it just looks not so good. Or you can blow it up so it fits the full resolution of your screen, and then it starts to get a little blurry. And that's what's happening on high DPI displays. That's what happens on your phone. That's what happens on the Pixel. The browser blows those images up to fit on screen. So, John, there's so many pixel types that we got to deal with. Why don't we talk about those for a sec?
So there are essentially three kinds of pixels that us web developers need to worry about. The first kind is the device pixel. This is one physical hardware pixel, a single RGB unit in the display, and it's the smallest unit. Okay, so then there's a second kind, device-independent pixel, or DIP, as we're going to call it from now on. It's an abstract unit. It's a fixed multiple of device pixels. So on, say, a 2x device, each device-independent pixel, DIP, is a 2x2 rectangle of device pixels. Okay, and then the third kind is CSS pixels. These are the ones we're all familiar with from CSS, the PX unit, you know. And so if you're following best practices and you've got a width equals device width viewport, we'll go into what it means later, a CSS pixel and a DIP are initially the same thing until you zoom in. When you zoom in, the CSS pixels get scaled up, but the DIP is a physical thing, and so that stays the same size. Okay, so this leads to some confusion, because they do seem quite similar ultimately. And in fact, if you read the specs like CSS and HTML, you'll notice the specs never actually refer to these dips. They always talk about CSS pixels, and I use that term, CSS pixels, to refer to both dips and CSS pixels. So you have to be a little bit careful. As web developers, we're most concerned about CSS pixels, because that's what we actually use in all our layouts, and this mysterious device pixel ratio. So let's go into a practical example. So this is an XS4. It's a 2x device, and we'll put on propeller hats in a minute to work out what that actually means and how we calculate it. But all you need to know for now is it's a fixed value for the device. An XS4 is also 768 device pixels wide in portrait, and to get the number of device-independent pixels of width, you divide this by the device pixel ratio, and you get 384. The width of this device in CSS pixels, well, that varies. So it varies based on the viewport, as we'll go into later, and it varies on the zoom level. On the mobile site, it'll often start off as being 384 pixels. It'll match the number of dips. But on a desktop site, it'll often start out being 980 pixels wide. And as you zoom in, the page is scaled up. It stays the same width, but because you can see less of the page on screen at one time, the number of CSS pixels across the width of the screen decreases when you zoom in. So Pete, how does the DPI vary across devices?
So it's really one of those fun things. The device pixel ratio can go anywhere from 1 for a simple 1x device, all the way up to 3 with the new Galaxy S4. And it's everything in between. The Galaxy, or the Nexus S is a 1.5x device, the Nexus 7 is a 1.3. Before this session, John and I did a little bit of math, and we figured out, we think for people sitting in the front row, that projector is about a 0.5x display, but for the people in the back, it's a 2x display. And we'll talk about that in a sec. So notice that the different DPIs between the Nexus S and the Chromebook Pixel, it's only 4 DPI different, right? Like 4 DPI should not matter on how much it goes from a 1.5 to a 2. It shouldn't matter going back and forth between the front row and the back row. It has to do with the distance that you're sitting away from the device. So I want everybody to do a little experiment for me. Take your hand, hold it out in front of your face, just like this. All right, now look at the size of your hand. All right, now bring your hand right up to your nose, like right up to your nose. Notice how your hand got bigger. You can take your hand down now, right? Your hand got a lot bigger, but your hand didn't change size at all, right? It comes down to the visual angle that you're looking at your hand. So the device pixel ratio is really about that visual angle. The CSS spec defines a pixel as the visual angle of a pixel at 28 inches for a 96 DPI display. So they've said, all right, a 1x display should have about 96 pixels at 28 inches. So for a phone, which we hold much closer, right, we need it to have a higher pixel density. So instead of having a 96 DPI display, it needs at least about 160 DPI. So actually when we did the math, this projector is about a 0.16 DPI if you're ever, want to do this. Now, if you want to calculate these out, the formula is here. You can do this on your own. It's not really that hard, and it's kind of fun just to sort of figure this out. In fact, your TV at home, if you've got an HD TV and you're sitting about 6 feet away from it, you've got a high DPI display at home. So I bet you didn't realize you probably have multiple high DPI displays at home. So we've talked about a lot of the theoretical stuff. Let's jump in and talk about the practical stuff, like how we actually do this.
So let's say you want to build a high DPI phone site. Okay, so you look at your Nexus 7 or whatever, and you see that it's 768 pixels, device pixels wide. This is what the spec sheet says. You go online, you look at google.com/Nexus 4 tech specs, and this is what you see. So you want to build a pixel-perfect design. The natural thing to do is to want a 1-to-1 ratio between device pixels and CSS pixels. So how's about this viewport? You say the width is 768, and that's how wide your page will be. Well, this is actually a really bad idea. If you look at what actually happens, on the left-hand screenshot, that's what you want to happen. And on the right-hand screenshot, that's what actually happens. It looks tiny. Because the page is so wide, the browser has zoomed out the page so that it fits fully on screen. And as a result, everything's gone really small. You can compensate for this, but you have to go through every single width, height, font size, margin, in every single CSS file of your entire site. It's a maintenance nightmare. It's just not worth it. It's also not even possible. In current browsers, when you use that kind of viewport, they'll mess up your font sizes, zooming will go weird, and it's because they'll think you're a desktop site, even though you actually meant it to be a mobile site. There was also a way of doing this in the past with target density DPI in your viewport. That's been deprecated. It doesn't work in Chrome, Safari, Firefox, etc. It never will, so ignore it. So instead of a really wide viewport, how about a fixed width viewport with a width that's more similar to the width of a phone? I've heard that 320 is common. So this is OK for legacy fixed width phone-only sites. but never use this for new sites or sites aimed at tablets. Why? Well, okay, let's look at this site on Nexus 4. Nexus 4 is 384 dips wide, and so it gets scaled from 320 to 384. That's okay, it looks decent. But the real killer is when you rotate the phone to landscape. And look at this. The toolbar is blown out of proportion. It's enormous. You can't even see the search box on screen because it's been pushed so far down as the page is scaled up. And if you try this on a tablet, can you imagine what's going to happen now? We're going to scale this up from 320 to like 1280, and it's enormous now. So yeah, the only valid way to make a mobile website is to design your site with a flexible width layout, even if you're making a dedicated mobile site, and use a width equals device width viewport. That one, in fact. So you'll see initial scale here. That's there to fix a feature in iOS where in landscape, rather than making your viewport wider, it'll zoom in on your page, which looks a bit weird. But the important thing is, this viewport allows users to zoom in and out, which is recommended for accessibility reasons. If you must disallow pinch zoom, which happens on a couple of sites, say you're doing a multi-finger touch painting app, or you're building Google Maps or something like that, then you can use the second viewport. But try to avoid it, because letting users zoom in is a nice thing to do. And so these two viewports give you the ideal page width on all devices. Use one of those for all mobile or responsive sites. Now, the device width we see mentioned here, it's actually in dips. So this means you get the same width of your page in CSS pixels, whether you're on a low DPI or a high DPI device. This is good. This means the CSS and JavaScript you wrote for your low DPI device will just work for your high DPI device. It's like what Pete was saying earlier about HTTP. Basically, the browser will just scale your site up, and it'll all look in proportion, like a HTTP playing SD video. Except the browser's a bit smarter, like for text and CSS features like border radius, it'll render it all crisply, taking full advantage of the available pixels. So the same widths, font sizes, borders, and so on work, but a few things you might want to tweak. So Pete.
Oh. All right. So if we want to display high DPI assets in our markup or in our CSS, there's a couple of things that we can do. For CSS, we need to use a rather large media query today. This is going to get a lot easier, and most browsers are standardizing on this line here. So you can see that we say min resolution 1.5 dppx. Whoever chose those set of letters right next to each other, I'd like to just hit because they're not fun to say. But in any event, 1.5 dppx will do that. But for today, you need to include all four of those lines. So you need the one for WebKit, for Opera. But I want to point out the third line there, the min resolution 144 DPI, because that's also going to work in the future. Now, you'd think, right, that this device, which is 326 or 236 or something like that, right, this should classify as that. What that number is that's the number of pixels at the standard level, right? So we've said that, or the CSS spec says it should be a 96 for a 1x device. So we want this to work on a 1.5x device, so we take that 96, multiply it by 1.5. That's where the 144 is coming from. So if we wanted it to be a 2x device, we'd need to do just 96 times 2. All right? So that's going to work great for displaying background images and stuff in our markup. If we want to query this in JavaScript, we've got the ability to be able to say window.devicePixelRatio, and we'll get our device pixel ratio back from the browser. Now, this works pretty much across all browsers. The only place where it doesn't work today is IE. They're aware of it, so hopefully we'll see that in the near future. But the nice thing about both of these is if you specify the markup in your CSS, or you have this, and it fails, it's going to work because you've already got fallbacks in there. Now, most browsers today are pretty awesome at sub-pixel layout, right? You can say, hey, I want something to be half a pixel wide, and it'll go do that thing. So that should mean I should be able to, on a high def or high DPI display, I can go do something like this, where I say, on a 1x display, I want a border of 1 CSS pixel, and on a 1x display, a 1 CSS pixel is going to be 1 hardware pixel, right? But on a 2x display, I want a half a CSS pixel, which is a 1 device pixel line. You think this works? Yeah, no, of course not. On Firefox and I've got it written here because I keep forgetting. Firefox and IE, they round up, and they're always going to give you a 1 pixel border. But on WebKit browsers, they round down, so you get no border. So you want to really test exhaustively if you want to use something like this, but realistically, if you want to have something that thin, I'd avoid it right now. It's going to be a little bit more of a pain in the butt than you want to deal with.
So now for some better news. If we're doing text, text is great. You've got a mobile optimized site with your width equals device width. Your text is going to be the same size in dips on all devices. You don't need to do anything. So if you get out your ruler now and you measure the actual physical size, it will differ slightly going from, say, a phone to a desktop or something. But that's because of what Pete was saying earlier about the viewing distance. And you'll find that the visual angle of the characters of your text will be the same even on the phone and desktop. So your text will be similarly legible. It'll just be rendered slightly more crisply on the high DPI devices, taking full advantage of the extra pixels. You're done here. Don't change a thing. Now, if you've got the misfortune of serving a desktop site to mobile browsers, now you're in for a world of pain. So, yeah, it's tricky. Desktop sites are 1,000 pixels wide, give or take a bit. The browser's going to zoom them out to fit the full page width on the screen. So on a portrait phone, which is about 300 to 400 dips wide, this means your site's going to be scaled down by a factor of 3 or so. Everything's going to be tiny. But that's OK. Users can zoom in, and by zooming in, text will become legible again. Right? Well, there's a slight problem with this, as always. So when you've got wide columns of text, suddenly everything breaks down. Once you've zoomed in such that the text is legible, the text is now wider than the screen, which means you have to pan from side to side for every line of text you're reading.
Oh, come on, who doesn't love that?
Woo, horizontal scrolling.
Yeah, no.
It's just not practical. So to combat this, when viewing desktop sites with wide columns, many mobile browsers reformat the text using a text autosizing algorithm. So on the left, you see this page as it was originally designed. And on the right, you see how it gets rendered in Chrome for Android on a phone. You'll notice that the wide left-hand column has changed text size. The header has gone from 24 to 32 pixels, and the main body text has gone from 15 pixels to 26 pixels. But in the meantime, the narrow right-hand column has stayed a constant 13 pixels in font size. So why are narrow columns different from wide columns? Well, this is what text autosizing does. It permanently scales the CSS font size of any wide columns of text, such that when you double tap to zoom in on that block of text, which fits the block to the screen width, the text will then be legible. This is used on mobile by Chrome, Safari, Firefox, Internet Explorer, notable exceptions being Opera and the legacy Android browser. You'll notice that neither the font size nor the layout change when you zoom in and out. This all happens when a page is first laid out. So it's used by 4 browsers, and you'll find that all of them have different exciting quirks. Woohoo! So by now you're probably wondering, how do I avoid text autosizing? It's kind of a fallback. The browser does it because it has to, but you'd never want it to happen. So because it triggers on wide columns, by far the best thing to do is just make your page narrower, okay? So So ideally, use responsive web design techniques to reformat your page for mobile device sizes, or if you must, use a dedicated mobile site. But whatever you do, just make sure it's a width equals device width for narrow page. If you're stuck serving a desktop page to mobile browsers, well, there's still a bit you can do. You can split up your wide columns of text into multiple narrower columns, side by side. And that way, because they're narrow, they won't get modified. So it sort of works, but it's not great either. And then finally, there are some ways you can disable text autosizing, but use this only as a last resort, okay? It'll disable it for the subtree under that selector, but only use it for like quirks, like a menu being auto-sized or other strange things going on. Don't use it for wide columns of text, or else when you pan from side to side, use again this whole problem that we had earlier before. And just going to give up on your site. So yeah.
So we've talked about text, we've talked about other stuff, but images really are one of the most important things on our websites today. We talked yesterday during the keynote that images are up to 60% or average about 60% of the weight of a page. So let's talk about the web images and the stuff that we're doing there.
So it depends on the type of graphic, what happens. With vector images, they'll seamlessly get crisper on high DPI displays. The same thing happens for text, okay? The browser just does everything for you. But with raster images, they'll get stretched, usually using bilinear interpolation. And you'll find they just start looking really crap. So there's an obvious and future-proof solution, is to replace as many raster images as possible with vector images. So how can you do that?
Well, it would be nice if we could use vector images for everything, but obviously we can't. For text or for graphics that have text on it, and if you want a specific font, using something like Google Fonts or other web font services, or Unicode characters is a really good way. You can use Unicode characters very easily for bullets as you're going through. If you're looking for a couple symbols, it works well for that as well. There's a bunch of really great web fonts out there, or icon fonts that you can use that give you really easy access to lots of different icons. But one of the problems with icon fonts is that they're single color, right? Like you can't change the color of one part of an icon and have another part some different color. So that's where SVG works really well, scalable vector graphics, because you can have it whatever color you want, and because it's a vector graphic, it can get bigger and smaller as easily as you want it to. And then finally, using CSS3, if you've got gradients, backgrounds, rounded corners, anything like that, works really well for that kind of stuff. Now, we've talked a little bit about background images already, so we won't spend too much time on this, but just want to call out again, you need to have these 4 lines. Now, this is great for the 1.5x. If you want to have a 2x, you'd need to have another one. Now, the 2x will work on this, and it'll get all the 1.5x, but you may want to go and do a 2x. You may decide that, at 1.5x, it's not worth my trouble. I'm just going to do the 2x. You may decide that you want to do one for everybody. And then one other thing, always having that fallback there. If you decide to use the background shorthand, don't forget to reset the size on an image, because the background shorthand will reset the size on that. Another technique you can use is using highly compressed 2x images. And this actually works fantastically well. You can see those 2 images there. On the left, they both came from the same original image. On the left is a 1x JPEG. So it's a JPEG that's 300 pixels by 300 pixels. I saved it as a quality 90 in Photoshop. I then, on the right-hand side, did the same thing. I took the original image, but I rescaled it. Instead of going to 300 by 300 pixels, I set it to 600 pixels by 600 pixels. And I set the JPEG quality to 30. So I went from 90 all the way down to 30, cranked it way down. The file size difference is huge, right? I went from a 62K file down to a 36K file, saved like 30-some-odd% on that file size. So great from a file size perspective. And when we actually zoom in and look at the image, it looks really good. In fact, even on a 1x display, I think it looks better than the original image. You can see, like, even look at the bow of the ship, look at the little bulb, look at the cranes. Everything is just much sharper. Now, this is great for most images, but there are a few places where this doesn't work, where you need to test this a little bit. If you have a lot of color gradients, you may see some banding in your colors. If that's really important, you want to make sure that you don't hit that. You can use WebP as another technique to make sure that your images look great. On the left is a 2x JPEG, saved at quality 80. So I cranked the quality up and I made them both the same size. And on the right is a 2x WebP image. All right, so the quality level is the same, they're both the same physical size, and it went from a 145K file all the way down to a 38K file. So huge file savings. Now, the one disadvantage that we have with WebP is that it's not supported across all browsers. So it means you're going to need to do some type of feature detection, either JavaScript, which there are some pretty significant disadvantages to that, or server side. Or you can use some services like PageSpeed, which is available as a Google service. You can download an Apache or a plugin for Nginx. Yesterday, Ilya Grigorik did a session on PageSpeed, and tomorrow he's doing one on WebP. So if this is an interesting thing to you, which it should be to every developer in here, I really would recommend checking that out. WebP can save you upwards of 30% in your file sizes, and that's huge.
Okay, so Peter covered how you do resolution switching, swapping out images for high resolution images today. In CSS, you use media queries to swap them out. And in HTML, well, there's actually no easy way. And so just provide a highly compressed 2x image, and it tends to work well. In the near future, there are some new features which make it slightly easier. In the CSS, there's the image set function. There's this part of CSS4. It's currently implemented in Chrome and Safari. And you provide a common separated list of several image URLs wherever you would otherwise provide a single one. And you annotate each one with the device pixel ratio for which it is designed. This is cool. The browser will automatically choose the most appropriate image based on the device's device pixel ratio. And in future, browsers might be even slightly cleverer. So a browser on a 2x device might still choose to download the 1x image if it's on a very poor bandwidth-constrained connection. Another nice thing is the browser will scale down the image to fit within the same original size. So you don't need a separate background size property as in the media queries approach. Whoops. But other browsers will ignore image sets. They don't know about it at the moment. So make sure to always provide a fallback image, like that top one. So there's an analogous thing for HTML, the source set attribute for the image element. This is still under discussion. It's not really implemented yet. But you can do the same thing. You provide a comma separated list of different files with their device pixel ratio. There's an additional feature. You can also provide width-based breakpoints, a bit like you get in media queries. So you can serve different images to mobile devices, to desktops, and so on. Okay, we still have to do resolution switching for fixed width images, both now and in the future. What about flexible width images? So by a fixed width image, I mean something like a logo or an icon, which stays the same size in CSS pixels in all devices. But a flexible width image is something which is, say, width 100%, and will actually scale with the page size. Unfortunately, these are much harder, and there are no good solutions today. But let's go through them quickly. JavaScript image replacement is quite popular. Typically, there'll be some script that runs and replaces the images at runtime based on the screen.width properties of the device. You have to be careful with this, because many of them don't load any images at all until the DOM content loaded event of your page, i.e. when you reach the bottom of your HTML. But by that point, about a third of the content of your page is already downloaded. And so what this means is that the images are going to start showing up really late. You can do JavaScript image replacement more efficiently. If you embed an image SRC in your HTML pointing to a very low resolution version of the image, which is always loaded, and then users will get an instant feedback. They'll see an image, and later on you replace it with a high resolution image. So the users don't have to wait, but they still get the full quality eventually. And you do a double download, but the first download is very small because it's a tiny, low-resolution image. So it's not so bad. You can also switch between images using lots of media queries if you combine the width and resolution media queries. But this gets really complicated really quickly. If you do this by hand, you're going to get it wrong. You need like 10 different lines, duplicating images and so on, and it's tricky. There are some server-side solutions. You can sniff the user agent of the device, and based on that, serve an appropriate image. The problem is Apple decided that iOS devices should have the same user agent both for Retina and non-Retina devices. So you can't actually tell how many pixels you need to serve them. Another server-side solution is set cookies on the client as the first thing in your head or something. And then when the browser requests images, it'll probably send those cookies, and the server can use the cookie to, where you'd have written the screen width and height and so on, to serve an appropriate image. This sort of works, but the first few images might be requested without the cookie, because browsers use a preload scanner, and so they'll start downloading images before you actually run the JavaScript to set the cookie. You can also set the base href of your page, such that any images with relative paths will be downloaded from a particular directory. If that directory includes the screen width and DPR, device pixel ratio, then the server can similarly use URL rewriting to serve an appropriate image for each type of device. So that's actually a reasonable approach, but it's quite invasive. You have to modify your server so that it understands things being requested from different directories. So it's not perfect. So what's coming up in the future? I mentioned briefly the image source set attribute. There's also a picture element which has been proposed as another way of specifying different images to HTML. But with both of those, you get kind of the same problems you had with the media queries above, in that you get this complicated, tangled mess of width-based breakpoints and resolution-based breakpoints, and it's really hard to actually serve the right images to the right devices. The client hint header is interesting. It's a proposal that browsers might in future send the device pixel ratio and the device width along with every HTTP request. This would allow servers to serve the perfect image reliably. None of this user agent sniffing or cookies or base href stuff. And my personal favorite choice is using progressive image formats coupled with smarter browsers. The idea is that when browsers see a wide image, they would download enough bytes to make that high quality. But if they see a narrow image, or they run on a narrow device, they would stop downloading the progressive image partway through. And so they would get enough quality for the size it's actually being displayed at, because they're never going to show it bigger. So that's under discussion, and we'll see how that goes.
Cool. Canvas images are another interesting one. Drawing on a canvas effectively is just a raster image, right? You're not doing anything different. It's not a vector image or anything like that. So if we want to draw on a canvas image, we need to make sure that it's scaled appropriately, that we've got the right number of pixels. So when we actually say, hey, browser, give me a canvas, it creates this thing called the backing store. And the backing store is what actually sort of stores the pixels and says, okay, this should be this. And this is where we want to make sure that we've got the right size. So we want to make sure that on a 2x display or a 1.5x display, that we scale that backing store to be the appropriate size so that our images appear sharp. Now there's a couple of times when we might not want to scale our canvas backing store. Think resource-constrained devices, some phones, some tablets. We don't necessarily want to go and scale those canvases bigger because every single canvas, we could be using 4 times the memory that we'd be normally using for a 1x canvas. So we want to be a little bit careful with that. So in order to scale our canvas, you'd think we could use something like this, right? We could say, hey, here's our canvas, and we're going to check our device pixel ratio. And if we want to scale it, we're going to say, okay, if it's bigger than 1, let's go ahead and we'll change the CSS size, and we'll change the we'll set the CSS size to its original size, and we'll set the canvas size to be whatever that ratio is, and then we'll do a little scale, right? That's going to work, isn't it? Yeah, no. WebKit browsers introduced this thing called the WebKit backing store pixel ratio. Say that 10 times fast. And the WebKit backing store pixel ratio always will return 1, except in Safari on the desktop on a Mac Pro Retina. All right? So it's literally one case that we need to deal with this on, where it returns 2 because it's a 2x display. They say, oh, hey, this is a big device. We should be able to automatically scale it for you. So they scale it for us. So we just want to double check what that value is so that we don't have to go scale it again, because we don't want to necessarily scale it to 4 times as big and use 4 times as much memory. Now, the good thing here is that Apple just checked in a change a couple of weeks ago, in fact, just at the end of April, that changes this behavior. So we won't have to deal with this in the near future, but for now, this is something that we need to check. So there's one last thing I want to cover before we start to wrap up a little bit, and that's just making sure that you serve high-res icon files to on all of your websites, right? All of you have been probably playing on your Pixels, and you've noticed some of those icon files look like, yeah, it's not pretty, right? So making sure that in your ICO file is a multi-resolution file, you've got a 32 pixel by 32 pixel and a 16 by 16 pixel. And if you're serving a ping, you want to make sure that you're serving a 32 pixel as well. So John and I went through and, there we go, spent a lot of time as we were preparing for this. We kind of realized that there were really 7 things. You can boil this whole talk down to 7 main points.
Mm-hmm. So yes, if you set width equals device width on your viewport, your CSS pixels will initially be the same size as your dips, your device-independent pixels, and so you won't have to worry about the 2 kinds of pixels until you zoom in, but even then you don't need to care about that too much. So life will be easier. If instead you set no viewport at all, or you try and set a fixed width viewport or something, you're going to be in a world of hurt. Your fonts are going to get scaled weirdly, your site may get scaled weirdly, zoom is going to be a bit weird. Yeah, try and stick to width equals device width whenever you can.
I'm going to show you 2, because that device pixel ratio varies anywhere from 1.3 up to 3. Somebody's probably going to do 4 at some point. John laughs at me when I say somebody's probably going to do 5 or 7 or 10, because somebody's just got to outclass somebody else, but it's true. Do you want to do this?
Yeah, so whenever possible, use vector image formats. They'll automatically scale and render more crisply on high DPI devices using the appropriate pixels.
Use the media queries whenever you can. It's a real easy way to specify the appropriate images.
For images in your HTML, it's a reasonable option to serve highly compressed 2x images and not worry about serving different images to different devices. And finally, for Canvas, just beware of that WebKit backing store pixel ratio. You don't want to end up scaling stuff multiple times and going from there. Now, the other thing that we wanted to mention was that the I/O organizers were like, you must have a call to action at the end of every session. They were sort of adamant about it. Well, ours is really simple. Go build beautiful. Go make the web look pretty, please. You guys all have pixels. You all have friends with high DPI displays. Just go make the web look nice. So with that, I want to say thank you guys very much. Thank you all.
Our slides are linked up there. John and I are going to head up to the 4 questions bar, and like good bartenders, we're going to answer your questions. Sadly, we're not going to be that good bartenders and won't be serving you booze. That was last night. But we'll do our best to answer all your questions and provide anything else that we can for you. So thanks, everybody.